When I checked the VSWR with the vector impedance analyzer, it was about 1.8, 1.9 for the R9 Super 8 antenna. I didn't think that was all that good, so I thought I'll see if I can do better. I began with a simple ground plane antenna, trimmed it to tune, and it was an VSWR was about 1, which is very good. So obviously things could be done better. So I decided to investigate a Moxon using the Moxon calculator for 868 megahertz. These are the dimensions of the antenna that I was going to have a go at making. I first of all took some plastic sheeting about a mil thick and cut it 133 mil by 60 mil. Onto the sheeting I stuck some paper and marked out the dimensions of the antenna that I got from the calculator. I then stripped some earth wire from some 13 amp cable and bent that, it's about a mil diameter, to shape around the marked out antenna on the paper. I intended to hold it down with zip ties, so I marked the position of some holes where the zip ties would thread through, and also the center position for the coax cable and the holes for the zip ties. I drilled those holes and also a larger hole at the top center of the antenna, which will act as a feed into the antenna from the coax. I then fixed the copper wire into place with zip ties and made sure it was more or less matching the diagram that I'd drawn. Now, regarding the length of coax, I understand that ideally it should be a half wavelength. The coax I was intending to use was the semi-rigid RG402, and the velocity of propagation of the signal in the coax is 69.5%, which means that the wavelength in the coax for 868 megahertz would be 69.5% of the wavelength in free space. So I used a calculator to calculate the wavelength of 868 megahertz in free space, which came out to 345 millimeters. Multiplied that by 69.5%, which came out to about 240 millimeters, half of that 120 millimeters. So the ideal half wave length of the coax would be 120 millimeters. I cut the coax to length, stripped off some of the screening and exposed the center core and fixed it into place and soldered the coax to the active element of the aerial, which I'd snipped in half at the center position. So the center core goes to one half of the active element and the coax screen to the other half of the active element, as shown there. Connected the whole thing to my vector impedance analyzer, gave it a tune by trimming the active element a little, and the VSWR was at just around 1.03, which I thought was quite good. So you can see here the ZO is 49.82, slightly inductive, I think that is. The S11 is -33, and the VSWR is 1.042 at 868 megahertz. So the antenna seems fairly well tuned. We'll see how it compares now. As a crude test before I tried it out, I took the quad down the bottom of the garden about 50 meters away, rotated the Moxon antenna through 360 degrees and recorded at each step the RSSI. You can see the front to back ratio is about 6 dBs, and the side to side is front to side is about 12 dBs. The front to back isn't as good as I had expected. I also took the transmitter around the other side of the house, and the signal remained about 80% all of the time. If I changed the antenna to the Super 8 antenna, I lost the signal when I took it around the other side of the house. Flight test now. Out about 2 kilometers, and the RSSI is 69% with the Moxon antenna. The same test with the Super 8 antenna, again out at 2 kilometers, and the Super 8 antenna is slightly better at 71%. So really the Moxon that I'd made had no great advantage.